I think we're filming okay.
Again, guys, I'm so sorry that you have to get video lectures from me. Are you able to find the videos? And I think once they start streaming, it takes a while. They buffer a little in the beginning, but then do they clear up a little bit as they go along? I'm gonna try to take more still pictures of the boards in between, so you also can see those. And guys, I mean, like, this is, I mean, I know it's a train wreck, but anything that you can think of to make the train wreck less of a train wreck, send them to me, okay? Because you're on the other end of the receiving the information this way. So you say, Dr. Warren, why don't you try this? Or Dr. Warren, you know, I want to make this horribleness the least horrible. Okay, so that's okay, which day are you? Are you A day or are you Z day? Okay, the Z-dayers, that's right, the Z-dayers. Another thing I don't want to do is bombard you, and you guys in video land back there, I'm talking to you too. I don't want to bombard you with a bunch of emails, because I get a sense you guys are getting, I don't even know how many emails a day you're getting from all your teachers and everything like that. So anything I can do to like minimize that, because I know I drop the ball all the time. So if you guys, I'm just going to post, you can just expect I'll post the videos in that on that announcement over and over again. So I don't need to send you an email, hey, it's going there. When it's done, when YouTube's done processing it, I'll get it up for you guys there. And I'll keep adding to the homework. When's your first WebAssign due? When's your first WebAssign due? When's your first Friday? Friday. How many people are made it on WebAssign? How many people are getting there? If not, like I said, Rachel McCoy is like rock solid. I've never seen a pitch she hadn't hit out of the park. So, also again, just don't pay more than you need to pay. If you use an ebook, it should be about $100. Okay, so I mean the software and the ebook together should be about $100. Okay, just so that we're all on the same page. What was the homework for today? You didn't turn it in, but what was the homework for today? That 1.4 thing, which was about what? What was that homework about? I guess lines, okay? And you can see here, I put up the homework through chapter 2. I put up the homework through chapter 2. So what I want you guys working on for tonight is 2.1. Okay, so and for you guys too, it's 2.1. Now this isn't an announcement. This is in this announcement right here. All you do is click on it, and it'll be there all semester long. Okay, here's our videos. So I'll put up our next video today after this. More and more people are contacting me that they're sick, or they've been in touch with somebody who's sick, and that they don't feel comfortable coming to class because they don't want to be the one responsible for making somebody else sick. But testing is falling further and further behind. Testing is falling further. So I don't know what's going to happen. I really don't know what's going to happen. But we'll get through, okay? We'll get through. We'll either do YouTube videos all the time. We're going to make it through, all right? So that, I just want to say that's these announcements. This is where they will be. And you guys, this is where they'll be. So I'm not going to send out an email to bother you tonight, okay? I want you guys working on the homework. I want you guys working on the homework in 2.1, okay? And then you can have lecture videos. If you're sick, guys, or you're not sure, I mean, I get it. Just stay, watch the videos. Contact me. Rest. Okay? The most important thing is to rest. This semester is going to come and go. Like I said, I had a semester where I got a 0.0, okay? And I'm still your teacher. So, you know, you can have a bad semester and it can still be okay. It's going to be okay. What I don't want you guys doing is stressing. Okay? I mean, I don't want you stressing. Okay? There's enough to worry about. This 2020, I don't want you stressing. Okay? Contact me. I don't have a lot of good advice, but I have a lot of scars. Okay? And usually I can find people that I can point you to if you need good advice. All right. Now this sounds bizarre because you weren't actually physically here. Okay, but what did we do last time? Which means video time. What did we do last time? Which week you watched the video? What did we do? What did we talk about? Domain and range of a function. Okay, and if we're thinking of the definition of a function, let's see what's there. Let's see what's stuck in your gray matter. A function is a relation. Its job is to assign, and it assigns to each element in one set called the and what about that range? There's a key word there. There will be a unique element in a second set called the range. And that's what it means to be a function. And then what we were talking about was, well, Dr. Warren, if our functions in Mat 205, the domain and range are going to be sets of, we're going to be taking derivatives and integrals and limits of functions. Should we know what the domain and range is? Like if we're thinking about it? But in general, they're going to be what? Real numbers. Very good. What's your name?
Trey.
Trey?
Trey, C-H-A-Y.
Sorry, Trey. I'll get it eventually.
All good.
Yeah, it's I just wish everybody knew everybody's name, including the people in the AA. I wish it all huddled together. I mean, it just works better that way. Chase said real numbers. What visual is used in elementary school to represent the real numbers? The number line. Now, if we have a domain and a range, we've got how many number lines? Two, and that's the problem. We've got two number lines, okay? And so what Descartes did in his genius, you put essentially the domain number line this way, which we call the x-axis, put an origin on here, and then he put the range number line going this way. These are at 90 degrees to each other. And this is called we gotta give you a hint there, the y-axis. Now before Descartes, I mean this really wasn't done. So a lot of mathematics was handwritten. But Descartes gave us this essentially this notation and this visual representation that makes things a lot clearer. And so like every single point in this coordinate plane, we think of as having an x-coordinate and a y-coordinate. So like we could say 3, 5, what does that actually mean? Explain that to a little kid. What does that mean? What does that mean? What does that mean? 3, 5, what does that mean?
The domain is
yeah, you go over 3 in the domain and you go up 5 in the range. Okay, now if I'm thinking about a function, what a function really is it's a set of ordered pairs. It's a set of x, y coordinates as far as what we're looking at. It's a set of x, y coordinates. And we'll write down the definition here again. Definition, you guys are going to help me without looking at your notes. And when you're watching the tape, like you guys are watching the tape right now, take notes just like you're in here. I want it to be as much of a classroom experience as possible. And it's so hard when I can't see your faces. It's so hard when I learned so much. Your eyes are the most important thing. So I can easily say when somebody's zoning, it's easy. Because I know what it looks like in the mirror, okay, every day for myself. But it's hard not to see your mouth. And it's hard when I can't volley. I love volleying stuff back. I love keeping you guys engaged. But if we go offline, then I'm just talking to that camera. And I gotta pretend there's a student in the room. I might have to set it up like the baseball stadiums, where I actually cut out cutouts of you guys and put you out in the stairs, so we can just I can have students to see. Okay, back to where we were here. A function, now you guys gotta help me out. We're gonna write down the definition because it will be on the first test, you just know it. Okay, a function is a relation that assigns to each element in one set called the Now you guys are gonna help me out. What follows this? What follows next? A unique element in a second set called the range. So there's our definition. There's our definition. Now when we think about a function, over here, you might not remember, what was our analogy? What were we using as our analogy when I first introduced the function to you? What was it? Football players and football positions, okay? And so if I think about it, like domain and range over here, we're picking three from the domain, and we're picking 5. You're like, Dr. Warren, seriously? I think you could actually put it so that it looks right. Yeah, sure, I can do that. I can change that to 5, 3. Picking 5 from the domain, and we're picking 3 from the range. Okay, so this is an ordered pair. This is an ordered pair. Now, if it's a function, then imagine that there was another ordered pair that was directly above this. Like what might its coordinate be? Just give me anything that would actually work. I want an ordered pair that's in the function that's directly above it. What would it be?
5, 8.
5, 8. But if you can see here, what we're saying is the function's assigning to 5 the function's assigning to 5 from the domain the number 3 in the range, but the function's also assigning to 5 in the domain the number 8 in the range. Would that be a function? Would it be meeting this unique requirement? Would it be meeting this unique requirement? And the answer is no. In that case, it's not meeting the unique requirement. So when you guys are using that vertical line test, you're really testing what part of the definition? The uniqueness. And a lot of students don't know that. They don't recognize that when they step in. They don't recognize why the vertical line test actually tests the definition of a function. Okay, so now let's pick a point over here that's the same height as this, but maybe like right here. Let's pick a point here. It's the same height as this, so y coordinate would be what? If it's the same height, this y coordinate would be what? 3. And maybe this is -2. And maybe this is -2. Let's just say that. So the function's assigning to -2 what value? The function's assigning -2 in the domain, what in the range? The function's defining what in the range? -2 is assigning to what in the range? 3. Is that okay? Is that okay? Is it okay for two different domain values to have the same range value?
Yes.
Is it okay for two different domain values to have the same range value?
Yes.
Is that's not violating? Sorry, Mike. I don't want to breathe on you. That's not violating the uniqueness requirement. Do you understand that? Does that make sense? And that's why the parabola that we learned so much in high school. It's like, I really wanted that to go through the origins. That doesn't help. Okay. Parabola. This parabola. Is it a function? Is it a function?
Yes.
Because it passes the vertical line test. Every element in the domain, if I pick this guy in the domain, I'm going to call him smiley face, is assigned to only one value over here in the range, which maybe I'll call ice cream cone. So this would be the ordered pair, this would be the ordered pair, this would be the ordered pair, I'll keep going. This would be the ordered pair. This would be the ordered pair. I'll start singing and dancing. You don't want that. This would be the ordered pair. Smiley face. Ice cream cone. But a lot of students don't come in with that knowledge of a function. They don't think of them as a collection of ordered pairs. What they do is they think of it like this. They'll often call this like the function f. And they'll say, well, f of smiley face is equal to f of smiley face is equal to f of smiley face is equal to ice cream cone. And that misconception, I mean, that's fine. That's fine notation. But that misconception ends up hurting kids in calculus, devastatingly so, when we're trying to understand the definition of a limit or derivatives. We've got to remember, when you're looking at this, ice cream cone's part of the what? I hit the ball in here. Ice cream cone's part of the what? Which set is it in? The range. It's part of the range. So when you're talking about f of smiley face is a range value. Say that. I know it sounds crazy in the video. I mean, you're going to go, this is what we're learning in calculus. F of smiley face, okay. F of smiley face is a range value. Smiley face is a domain value. But f of smiley face is a range value. And let me show you where this burns students quite a bit. You might have a graph like this, call it F. It's a collection of ordered pairs. It's a collection of a bunch of points on the plane. Does that make sense? It's a collection of ordered pairs. Now I've got to ask you, is it a function? From what you learned in high school, does that actually represent a function?
Yes.
Some of you are just staring out into space like I would. Does it represent a function?
Yeah.
I want to play music now. That's what I would do. I'd put on like top 40 and we'd get up and dance. And then YouTube would flag me for like copyright violations, which just pisses me off. You know, I'm like, okay, I'm using an excerpt, English will follow. I'm using an excerpt of a song to try to get my kids awake, and you're gonna flag me for a copyright violation, like I'm gonna use this to make money? Okay, but back to where we were here. Let's just pretend, dance. I don't think that's gonna sell. Okay, but it did maybe wake you up. It did maybe get you. Okay, does it represent a function? Does it represent a function?
Yes.
Because it passes the. Every element in the domain gets assigned one and only one value in the range. But let me just show you this. Let's just call this value right here C. There's C. It's in the what of the function? It's in the what of the function? Domain. Show me where f of C is. Now you draw that. If I draw, you draw. So if I draw, you draw. You mark where f of C is. We got our function. This is where I really want to be back among you. This is where I typically be all over the room, up and down, looking around, seeing what you're writing down. Right now, I feel like a lion at the zoo. Okay, I see all of the prey, and I can't get at you. All I can do is pace up here like a lion, back and forth along the fence line, 6 feet away. 6 feet away. You're good. You're good. I'm probably. Okay. So now, everybody have their f of C? Everybody mark their f of C? Guys, we're going to leave our pride out the door. So ball up your pride. And you at home, ball up your pride. Ball it up. Ball up your pride. Ball up your pride. Come on, ball it up. Throw your pride out the door. Throw your pride out the door. Just think about that calculus readiness test. Think about how ready you are for calculus according to that test. Where's our pride? Where's our pride? Out the door. Do we have a lot to learn to get ready for calculus?
Yes.
And that's what I'm trying to do here. And you guys at home, I'm trying to do the same thing. So I said mark an f of C. You better have a damn f of C somewhere on that graph. Okay, now what I want you to do is hold up your graph and show it to somebody else. Don't breathe on them, but hold up your graph and show it to somebody else. We're putting our pride out the door. So hold up your graph. Hold up your graph. Don't breathe, but.
Yeah.
Okay. So I haven't been around the room. But if you marked this as f of C, we're screwed. If you mark that as f of C, we're screwed when we try to understand what a limit is. You're like, Whoa, Dr. Warren, that's not f of c? F of c is in the what of the function? The range. What represents the range?
The y-axis.
Yes. The function is a collection of ordered pairs. This is definitely important. This is definitely important. It's the y-coordinate. It's the y-coordinate on the graph of the function. This is coming from the domain, and this is coming from the range. F of c is back here. It's in the range. It's in the range. And so, I mean, like, and guys, I mean, it makes all the difference in the world when it comes to trying to understand limits. Okay, so this is where f of c is. So if this is d, mark a d. Give me a d, d. Okay, mark f of d, mark f of d. And you guys at home better mark your f of d. So where's f of d? What do we do, guys? How do we find f of d? What do we do? What do we do? Help me out. We go up, and then we go straight over. It's kind of like a game of catch. I kind of meant like Field of Dreams. You got to throw the ball with your dad. And I had 5 daughters, and I always thought one would go out and throw the ball with me. None, not one. Let's go throw the ball, Dad. Let's go throw the football in the yard. No. Okay, but this is a strange game. Because like the son is here, throws the ball this way, and Dad stands over here, and when it hits this thing, it suddenly shoots off at a right angle. So it's a little bit, it's not quite like, well, it's kind of like Major League Baseball right now. Okay, no, not really. Could you imagine sitting on a pitching mound? If you were a pitcher and could do that, if you could throw it and it go at a right angle, you imagine the batter's over here and they're like, fling, and then it booms that way. Yeah, hey, that's my stuff right there. Doesn't that look like somebody who's never actually thrown a ball ever in his life? Okay, so back to where we were here. How many people like, so if this is x, where's f of x? If this is x, where's f of x? If this is x, mark f of x. If this is x, and you guys mark f of x. Oh, I guess I promised I would actually take pictures of the board. And you're like, you don't need to do that, because you're in the room. You're like, don't waste your time, Dr. Warren. But if you were back home watching this disaster, you would be like, do you think you could send me a picture of the board? Okay, can I erase this? Can I erase this? Can I erase it? Gently stand up. Gently stretch without breathing. Gently sit back down. Like I said, now we'd be doing burpees on the floor because I knew that would get you awake. I really think I could sell my math classes as UREC classes also. Cross-list it with UREC. Kinesiology and calc. Okay, lines. Are lines functions? Depends a little bit. What's the only kind of lines that aren't a function? Vertical lines, but any other kind of line is a function. So if I'm thinking about a line, how many points determine a line?
2.
2 points. So let's just take 2 points. So give me 2 points, any 2 points. You guys make them up. What numbers do you want? Give me anything.
2, 5.
2, 5. Okay, and then how about this one? What do you guys want for that one?
7, 13.
7, 13. So part of your homework was like given two lines, can you find the equation of the slope? Could you find the equation of the slope? Now what does the slope represent? What does the slope represent for the line?
The change in y over the change in x.
The change in y, yeah, the change in y over the change in x. So I've got this, I'm gonna draw my line through it like this. I'm gonna draw my line through it like this, and it represents the change in y over the change in x. Now, I didn't quite get it when I was in elementary school, when they were trying to talk about slope. They would ask, is the slope positive or is the slope negative? And I was like, well, what does it mean? They're like, well, it's kind of like the steepness. And they're like, is it positive or is it negative? And I was like, I'm like, well, is it kind of like if you were walking up the hill or down the hill? What would you say? Is it positive or is it negative? And I was like, well, it depends on which way you're walking. You know what I mean? Like, if you're walking this way, then it looks like I'm going up. But if I'm walking this way, it looks like I'm going down. And the teacher was like, what? And I'm like, no, it's the way you read. It's you do it the way you read. And I was like, well, that's the problem right there. I don't read, so no. So when we're reading like slope, being positive or negative, it's left to right. It's left to right. So we would say this slope is positive, but if the line would be going like that, the slope would be negative. Okay, now let me try to justify for you why the slope is what it is and why it's important. Did we do this in a class yet? Did we talk about this in the class yet? Okay, because I think a lot of kids walk into my class not really understanding why the equation of the line is the equation of the line. And it undermines them because we're going to be talking about lines quite a bit. So I'm going to pick any other point on the line. So you guys do the same thing. I draw, you draw. Okay, because it's any other point, say that. You should have said it back there too. Sorry, I'm not going to come back and read on you, but I still want to get back in that camera and be like right in their face. Because it's arbitrary, I'm just going to call it xy. I'm just going to pick it as the ordered pair xy. Does the line I drew, is it a function? Is the line I drew, is it a function?
Yes.
Does it pass, does it meet the uniqueness requirement that's in the definition?
Yes.
So I've got that. Now what I want you guys to do is this. I want you to draw parallel lines through that point, a horizontal parallel line, a horizontal parallel line that way, then a horizontal parallel line that way. So draw those three horizontal parallel lines. Then once you're done with that, I want you to draw three vertical lines. Like that. So it's almost like we're laying a grid out on a street. We got this cross street going through on our map. Now, what kind of angle is this? What kind of angle is this? What kind of angle is that right there? Yeah, you got your horizontal, and you got your, you got east-west and north-south. So that's going to be a right angle. What kind of angle is this? What kind of angle is this? Right angle. Now, because all of these horizontal lines are parallel, are they all not the same? Don't they all have zero slope that we're looking across? Since they're parallel, is this angle the same as this angle? Is that angle the same as that angle? Because they're parallel, we've got these corresponding angles, so they're the same. And we also know all three angles of a triangle must add up to, all three angles of a triangle, make your geometry teacher happy. All three angles of a triangle must add up to 180 degrees. So then I know then that this angle plus this angle plus this angle is 180, and this angle plus this angle plus this angle is 180, which means then these two angles also have to be the same. Those two angles have to be the same. Which means this bigger triangle and this little triangle have the same angles, which makes them, make your geometry teacher so proud of you, which makes them what kind of triangles? Not congruent. If they would be the same exact size, we'd say they were congruent. Anyone? Ferris Bueller's is out. Anyone? What?
Right.
They are right triangles, but looking at a relationship between the two. How about you in video land? No, that's not right. Similar? Yes, that is right. Let's give it up for the person who has said that. They were clapping for you. They were clapping for you. Okay, so they're what kind of triangles? And what do I know about corresponding sides of similar triangles? Dr. Warren, forgot. I got a 5 on that test, that pre-assessment test. I got a 5. What do we know about corresponding sides of similar triangles? They're proportional. Say that. Now you're going to say it all together in one sentence. It's like I'm teaching you a song. Corresponding sides of similar triangles are proportional. Now say the song. It's like middle school choir right now. Let's try it again. No mouthing it. Let's try it. Corresponding sides of similar triangles are proportional. Okay, so now I'm going to look at this. I've got this big side. I've got this big side here. But what are the coordinates of that point? What are the coordinates of that point? So if this is 2, 5 and that's 7, 13, what are the coordinates of that? What are the coordinates of that?
7, 5.
7, 5. You're over 7, up 5. Now this one's going to have a variable in it. But what are the coordinates of that corner down there where that right angle is? What's the coordinates of that one there? What is that? Dr. Warren, no. How high up is it? How high up is it? How high up is it?
13.
13. How far over is it?
X.
X. So this would be like 13x. Okay.
Wait, X 13. X 13.
See, I need you guys. That's how I had that 1.9 high school grade point average, stuff like that all the time. Every single test, every single quiz. And then instead of checking it, I keep moving through. I'm way behind anyhow. Let me just move through with this. Okay, now can somebody tell me how long this side is? Can somebody tell me how long that side is? 5. How'd you get that?
7 minus 2.
Now you're going to be angry with me because I'm not just going to write it as 7 minus 2. If I write it as 7 minus 2, you write it as 7 minus 2. I'm teaching study habits all at the same time. How many freshmen do I have? I'm so sorry, guys. It's got to be the most surreal thing. I mean, you're in dorm, you're like, I wonder how many people around me have COVID. And you're just like, I wonder if this ventilation thing actually is any good. I wonder if I should sleep with oxygen on. It's got to be surreal. I'm going to go to the shower, and I hear somebody coughing down the hall. Maybe I won't pee now. I'll just wait. And then you're dealing with all of the stresses of freshman year. I mean, and anybody who's not been a freshman, it's pretty stressful, right, guys? When you're dumped by your parents at college. Fine. Cry. But they did a study at Cornell where they did high stresses during life. Number 1 was loss of a child. If your child dies before you, that was the number 1 stress that typically most people would ever go through. But not too far down on the list was freshman year at college. Because you're in a place with 18,000 people, and you say, is it possible to be lonely with 18,000 people? Yes. Is it you're away from your home for the first time? You're trying to get used to things, and now we're wearing freaking masks. And you got all this other layer on top of it. Okay? So I know I should teach me math, Dr. Warren, but I just want to tell you guys, it's okay. You can talk to me. I don't have any good advice. If there's something you're feeling stressed, you talk to me, okay? I at least can air it out. Okay, well, back to where we were here. And in apartments, it's not much better. You look at your roommate every time, it's kind of suspect. Who are you with? Okay, back to where we are. What's the distance here? What's the distance here? What's the distance there? Dr. You're one here. What's that? What's this distance? 13 minus 5. How many people see that's 13 minus 5? Okay. Now, this is a little bit harder. But what would represent the distance between here and here? using that same idea, what would represent that distance of that side of the little triangle? What would represent that distance? X minus 7. And what would represent this distance here? Y minus 13. Okay, now let's go back to what we were chanting, our song. What was our song again? And you at home, you should say it first. What's our song? Similar triangles are proportional. So what I'm going to do is I'm going to look at this little side. I'm going to look at this little side and I'm going to look at this. And then I'm going to say that y minus 13 over y minus 13 over the big side, corresponding sides of similar triangles, corresponding sides. They corresponding sides over 13 minus 5 would be equal to, they're proportional, would be equal to what? You guys tell me out. If we look at the other side, it would be equal to x minus 7 over 7 minus 2. How many people followed so far what we've done? I mean, if you raise your hand if you actually followed. Okay, so now, what I want to do is I want to like take this guy. Now this is where the algebra comes in. This is where that assessment test becomes an issue. Okay? And I'll do it with numbers first. Is 5 times 3/7 the same thing as 5 over 7 times 3? Is 5 times 3/7 the same thing as 5 over 7 times 3?
Yeah.
You're like, well, I don't know, Dr. Warren. Well, let's just see. Is this the same thing as 5 over 1? And is this the same thing as 3 over 1? And how do you multiply fractions? Good, yeah, top, bottom, bottom. Do you get the same numbers? Yeah, so 5 times 3/7 is the same thing as 5 times 7 over 3. So if I look at this, now you guys watch what I'm going to do, because your ability to zone is like mine. I'm going to multiply both sides by 13 minus 5. I'm going to multiply both sides here by 13 minus 5. And when I do that, I'll get 13 minus 5 times x minus 7 over 7 minus 2. I haven't messed with this fraction at all.
Wait, is there a reason we didn't like simplify it?
Yeah, it's a good question. What's your name?
Miles?
Miles, I know it's probably driving you insane, but just wait. There'll be an aha, I promise.
Okay.
Not that one, I don't believe you. Okay, this is the 5, this is the 3, this is the 7. This is the, that's the 3. But this would be the same thing as saying y minus 13 is equal to, this is the 5, this is the 7, this is the 3, would be equal to 5/7 times 3, which would be 13 minus 5 over 7 minus 2. And then what would be out here? What would be out there? What would be out there, guys? What would be out there? The x minus 7. Okay, now, Dr. Warren, where are we going with this? Well, we started with a line. How many people remember we started with a line? 2 points. How many people got that? We picked an arbitrary point on the line. Then we set up similar triangles, and then we got some distances here. Then we used the fact that they were similar, and now we've done a little bit of algebra. What's the hardest part so far? Probably the algebra, right? At that point in time. But look at what you have right here. Look at it. Is this not y2 minus y1 over x2 minus x1? Is it not y2 minus y1 over x2 minus x1? That's the what? The slope. So this is the slope. Now, most of the time, your teachers in high school aren't gonna let you leave it in this form. They're gonna want you to get y all by itself. They're gonna want you to get y all by itself. So then you have y equals 13 minus 5. Miles, I promise you,
Okay.
I will simplify this. And then we're gonna take the 13 to the other side, plus 13. And then they go, okay, y, everybody knows 13 minus 5 except me. 13 minus 5 is 8, 7 minus 2 is 5, x minus 7 plus 13. And then they're gonna make you distribute and simplify. And the reason they're doing that, I'll say it again 5 times. I don't know why I think if I repeat myself, that's real good teaching. Just say it over 5 times. Then that's good teaching. You say it once, that's not good teaching. The reason they make you do that, they want it in function form. They want it to be like f of x equals. So it gives you the function form of the line. But this form is actually preferable in this class. This form is actually preferable in this class. And this is called the point slope. The point slope form of the line. You need to know a point, and you need to know the, it's all name, and the slope. So in general, if you're given 2 points, x1, y1, and x2, y2. Now, I don't care which point you pick for the point slope form. The equation of the line looks like this. Okay. The equation line, what form is this again? What formula? Point slope. It's y, I'll pick the first point. Y minus y1. It could be y minus y2. You get the same, you'll end up with the same thing if you simplify. Equals m times x minus x1. Where m is the slope. And what's the slope? How do you get the slope again? You should have this memorized from high school. Slope, I say slope, you hit. I say slope, I pitch a slope right down the middle of the plate, you knock it out of the park with a y2 minus over x2 minus x1. Now I've got to ask, is that not what we got? Is that not what we did? So if anybody asks, where does the equation of a line come from? You can tell them, it's from similar freaking triangles. That's where it comes from. It's from similar triangles. So like for example, if I give you 2 points, 2, 5, I guess 7, 13, and you really want to do the equation of the line quickly, you can just say, okay, well, it'll be y minus. If you have the formula down, if you have this down as a flashcard, you just say, oh, it's y minus 5 equals m. Okay, we've already done m. We've already worked it down to the 8/5 times x minus 2, 1.9. X minus 2, and you're done. Or you could say y minus 13 equals 8/5 times x minus 7. Both would simplify down to be the exact same formula. Both would be the same equation in one. Okay. Now, slopes of lines. Sorry. Time is class end.
5
Oh my gosh. Did you guys learn anything today? Have you learned anything so far today? Does this help as far as lines?
Yeah.
Did I assign any problems with parallel and perpendicular lines? Was there anything with that in the homework? Was there anything in 1.4 about that?
Yeah, I'm pretty sure there was.
Okay, so I'm gonna. What's your name again? Yeah.
Miles.
Miles, I'll get it, I promise.
Okay.
Miles, I only care about you, I'm teaching you. That'll make everybody else jealous. I learned that to do that with my daughters. You care only about one of them, and the rest of them might listen. Okay, Miles, I only care about you. Miles, what do you need to find the equation of a line? What do you really need?
2 points.
2 points, and then you could use the point slope. You need a point and you need slope. Does that make sense? Can you get slope if you got 2 points?
Yeah.
If I gave you slope and I gave you a point, do you think you could get the equation of a line? So if I said, okay, well, here's your point, -2, 4. -2, 4, and the slope is 8. Could you find the equation of a line? Do you think you could do that? You say, Dr. 1, it's going to be y minus 4 equals 8 times x minus -2. This would be x plus 2. So you'd be done. So you really need slope and you need I'll try that again. So you need slope and you need a point. But typically to get the slope you need 2 points. But if 2 lines are perpendicular, what do we notice about their slopes? Okay, let's go to the easy one. If 2 lines are parallel, what do you notice about their slopes? They're the same. But if 2 lines are perpendicular, let's do the easy part. As we read left to right, one's going, the other's going, so they're going to be opposite signs, right? They're going to be opposite signs. Okay, so there's that one. How would I draw a perpendicular one? Oh gosh, nobody can see it in the video. I'm so sorry. What time is it now? Tell me exactly.
12:46.
What?
12:46.
Awesome. What's your name?
Lainey.
Thanks, Lainey. Like the shirt. Okay. I wanted this to be kind of like even steeper still. Okay, so you draw, I draw, you draw. I draw, you draw. Crap, I want it steeper still. Oh man, could you imagine like if we didn't read left to right and you were skiing down that thing? Could you imagine? That would be at least black diamond. Okay, now draw the line that's perpendicular to it. So we got to make a what kind of angle? We got to make a what kind of angle?
Right.
Right angle. We're going like this. Now, which would you rather ski down if you could ski either direction? Which would you rather ski down? Okay, come on, don't be lame. Which would you rather ski down? Like Dr. 1, I want that one. I want that one. This one looks a little boring. These are cross-country skiers. I don't even know how that's an Olympic sport. I'm going to offend somebody in the video. I know. Okay. So we got this. Are their signs different? Are their signs different? Is one positive and one negative?
Yeah.
But do they have the same slope? Do they have the same slope?
No.
Okay, for lack of time, I can't quite argue all this for you. But if we dropped an XY axis on here, what we can end up showing is that these two triangles are, what we can end up showing is these two triangles are similar in the court. What's our phrase again? Corresponding sides of similar triangles are proportional. So we can end up showing that if this slope is 7, that this slope is -1/7. If this slope is 7, by similar triangles, we can argue that this slope is -1/7. If you have a line whose slope is 2/3, what would the slope of the line that's perpendicular to it be?
-3/2.
-3/2. What would the slope of the line that's parallel to it be? 2/3. Do you think you can do your homework now in 1-4? Does this give you a little better shot at some of it? Okay, a lot of it's review. I want you working again, finishing that homework in 1-4. I want you moving to 2-1, reading 2-1, looking at the homework in 2-1. I'll try not to breathe on you. Thanks, guys, for playing. What's your name again? Lane. Thanks, Lane. Thanks, what's your name?
I'm good.
Zach? Thank you. And you're? Jay. Nick? I'm not gonna remember. Avalon? Oh, nice to meet you, Avalon. Zach, that's what Zach. Jonathan? Miles.